so special visit. Pleasure and inspiration marks the way impacts on us the passage of Professor Fredrik Heintz through Rio, and very especially here at this meeting center of Institute Tercio Pacitti of Applied Computation and Research, in a joint venture with the broader institutes of Computer Science, Mathematics, and Computer Systems and Engineering of Federal University of Rio de Janeiro, herein very well represented. Considering this partious time we got to organize it, it's even more remarkable the unexhaustible efforts done by Professor Stefanella Boato of the Institute of Mathematics, ahead of the International Chamber of the Center of Mathematics and Earth Sciences, to make this running in time and to join people, to connect people. We are sincerely, mostly indebted to her too. What brings us together is the emergence of scientific approaches to our unavoidable pluri-epistemic problematizations and methodologies to artificial intelligence and its countless applications, found in an age of AI and the human, in pace to the current and far from exhaustion age of the brain. This morning represents a window for learning with Professor Heintz and for sharing ideas, plans, expectations, hopes, and fears, and especially to make bridges. We are absolutely indebted for your time, Professor Heintz, and your generosity to share with us your seminal experiences and contributions to this effervescent and urgent thinking. Nothing seems more resonating than doing it during these effervescent, boiling days of summer at Rio. Thank you very much. Thanks for you all. I would like to ask Dr. Priscila Lima. She integrates the Institute Tercio Pacitti of Applied Computations and Research, and also the program of Computer Systems and Engineering. We are pleased to have her telling us a little bit more about Professor Heintz.
Well, I will summarize it because there is a lot to talk about him. He is a guy that has a vast experience. He does several exciting things in AI, which I share his passion for these things. But I'll just say, Professor Fredrik Heintz is professor of computer science. His research focus is artificial intelligence, especially trustworthy AI, autonomous systems, stream reasoning, and the intersection between knowledge representation and machine learning. He leads the reasoning and learning lab within the Division of Artificial Intelligence and Integrated Systems in the Department of Computer Science. Fredrik Heintz is Program Director of WASP-ED, then I'll have you look at because I can't pronounce all of the terms here. He's Director of the Graduate School for the Wallenberg AI Autonomous Systems and Software Program, WASP. Director of the Linköping University's AI Initiative, Coordinator of the Taylor ICT Network of AI Research Excellence Centers, President of the Swedish AI Society, member of the CLARE Extended Core Team, member of the Euro AI Board, member of the European Commission High-Level Expert Group on AI, fellow of the Royal Swedish Society, and he also gave a talk at the the Center for AI, the C4AI, yesterday. Yeah. So it's a real privilege. Thank you very much.
So thank you very much for making it. I don't hear myself.
Oh, sorry?
I hear myself.
Ah, tá. Ah, tá.
O pessoal online não está conseguindo ver os slides. E porque não tem slides ainda.
Né, professor?
Yep. Well, I hear it a little bit, but it's better at least. Anyway, so thank you very much for the very kind introduction and for the invitation to host me here. So I think it's a great pleasure to visit, and we already had so many interesting and excellent discussions. So I look forward to the continuation. So basically, what I wanted to do here today is actually give a little bit of background to the work that we have been doing and some of these acronyms that was mentioned in the bio. And then I will be talking about the kind of main topic of this talk, namely this: how do we work towards more trustworthy large language models? So personally, I mean, I've been doing AI research for about 25 years, and actually I started out doing a lot of work on autonomous systems. So we built fully autonomous helicopters about 20 years ago. So these are 100 kilo platforms, about 4 meters rotor diameter. So it's like this desk here, about that size helicopters. And we made them fully autonomous so that they could carry out different types of missions together with first responders. And actually, we're completely autonomous in the sense that we're not dependent on anything outside of these systems. So even if they're lost forever, we use GPS if GPS was available. But if GPS signal was lost, we could use visual navigation to then find our way home to a base. And then we had a special pattern on the ground, and then we could do autonomous landing without any external sensors, just a downward facing camera and pressure sensors was sufficient to be able to do that kind of landing. We then also built our own quadrotor platforms. We've been doing UV platforms ourselves for about since 2000. But actually, if you know this cage, you know this UVs, where you have a cage around it so you can bounce it around. I think we were the first to do that in 2004 or so. And then we built our quadrotor platforms. But of course, today we mostly use commercial platforms. I've also been the national lead of the Swedish national team in robot soccer. We were not very good, but at least we participated. And today we are working on a public safety arena where we have a large number of different UV platforms and boats and robot dogs and all these kind of things interacting with humans. So I mean, my background is really this: how do we get AI technology into fielded robotic systems so that they can provide value to the end users? So that is where I started. I would say that today my activities are much more less robotic, I would say, but still this is the kind of background I come from. And the university I come from, we actually were first in Sweden with computer science and the first in Sweden with AI, as we have been doing AI research since the 70s. So actually the first professor of computer science in Sweden was Erik Sandevall, who when he was a PhD student, his supervisor realized that I cannot teach him anything more, so he sent him to the US to study with John McCarthy and Marvin Minsky and these people who founded the AI field. And then when he came back, he became a professor, and then really started computer science in Sweden. So we've really been doing this AI work for quite a long time. And he's also my academic grandfather because his PhD student was my supervisor. So if we then look at the kind of ecosystem that we have in Sweden, we actually have a quite good ecosystem starting from a more basic research program. So this is the Wallenberg AI Autonomous Systems and Software Program. So this is a basic research program that's actually long-term. So it's like a 15-year program with a total funding of about $600 million US. So we're having a large size program there. And we have the goal of educating at least 600 PhDs in the areas of AI, autonomous systems, and software. Currently, we have examined about 160 PhDs, so we still have at least 450 to go. My expectation is that we probably will have more like 700 or even 800 PhDs in the end, but definitely a very large-scale program. And there I've been responsible for building up the graduate school. Now I've handed over the graduate school, so since a few days back, I'm now a co-director of this program with a focus on collaboration, international collaboration. We also have 2 sister programs, one on humanities and society, so basically studying the impact of AI on society and say legal, ethical, economical aspects of AI. We also have this educational development program that I coordinate, where we're then looking at how does AI transform higher education and how should we in higher education adapt to be able to deliver the kind of volumes of expertise that we need in AI, but also, which I think is the more interesting challenge, is how do we scale out AI from the kind of technical areas where we are used to working on it to also include the other, all the other subjects at the university. And actually here, Linköping University has said that we will introduce appropriate AI content on all our education programs. So now we're working on how and what should we teach in all the different programs in order to prepare the people for AI-related activities. We're also working with more professional development, so basically providing courses and teaching and education opportunities for people, professionals. We have an organization called AI Sweden, which is a national initiative towards accelerating the use of AI in society, both public and private sector. And then I have been coordinating a number of large-scale EU projects. So the Taylor project was the European Network of Research Excellence on Trustworthy AI. So this project ended in the fall. So now we are, it doesn't exist anymore. But we also have this Trust LLM, which is the project that we'll be talking about, where we then are working on building more trustworthy and factual large language models. And there's a lot of work happening on the EU side as well. And of course, Linköping University is one of the key players in this. So actually, we're the host of all of this VASP program, the VASP ED program. Well, we also have this course Elements of AI, where we teach everyone the basics of AI and this program. So we are really one of the key actors in Sweden. And actually, one of the things that we are very well known for is that we host many of the national research efforts. So not only the Sweden's largest research program, VASP, material science for sustainability. So this is like $300 million, again, I think over 10 years or so. And we also have the National Center of Medical Imaging Sciences Visualization. And we also host all the national academic infrastructure supercomputing. So we host all the supercomputing in Sweden for this. So we are now been actually awarded one of the Euro HPCs. So in Europe, we have this HPC networks for high-performance computing throughout the union and making this available. Linköping is one of the nodes. And we also got this thing called an AI factory as one of 7 in the EU, where we're able to make this high-performance computing available to SMEs and to different organizations. So we're really also combining both the science with the infrastructure with the storage research initiatives. We also cover basically all aspects of AI within universities. So AI is a very broad field, many different subdisciplines. We cover all of these different subdisciplines within a university. And then just finally a little bit about the division that I lead. So I lead Integrated Systems, AIICS division. And the reason we call Integrated Computer Systems was because we really worked on this integrating AI into computer systems, building these physical artifacts where AI was a major component and major part. So that was that work was still led by Fredrik, who was the head of the division before. Now he's handed over to me. And we have one group working on machine listening. We have one group working on natural language processing. Then we have my group working on machine learning. And theoretical
basically studying computational complexity, often related to AI-related problems. So basically understanding the fundamental limitations and fundamental possibilities of computing, and especially AI. And finally, I am also, the reason I'm here, I've been appointed as Sweden Brazil Professor Chair in AI and Autonomy, with basically the goal of stimulating collaborations between Sweden and Brazil in the areas of AI autonomy. And this is part of this bilateral work between Sweden and Brazil. And we also have a working group on AI and digitalization, where I'm the Swedish chair of that. And there is a Brazilian chair, which actually I don't know who it is because it's being changed. So I will meet the ministry tomorrow, so hopefully I'll find out who the new person is for Brazil. Anyway, so we're all working bilaterally on engaging and stimulating collaboration. So that was very briefly to some of the things that's a little bit about me and the work that we do. So now we'll go more into the main talk towards trustworthy large language models. And we all know that AI development is fast, and I actually think this is driven by a number of high-profile applications. And then we'll start out with this kind of self-driving cars that was catching everyone's imagination about 10 years ago or so, and which were using a lot of this AI technology to build self-driving cars. Then it was this superhuman performance in games. Of course, it was mostly Go. I mean, 2016, I think it was, when Google defined beat the best humans in Go. But then after that, it's been basically every other game like Poker and StarCraft and Bridge and Dota and so on and so forth. So it doesn't really matter if it's a perfect information game, if it's hidden information game, if it's a multiplayer game, if it's a single player game, if it's opponents or teammates. I mean, if you have something that's really well defined, such as a game, it's just a matter of time before the computer is much better than we at playing a game, because the rules are well defined, the goals are well defined. It's just a matter of finding the optimal strategies, and that's what computers are good at. And we can also start to see that if we look at more cognitive capabilities, that actually these kind of AI tools are reaching or maybe even surpassing at least some kind of average level human capability in these areas. So of course it's very interesting to see what will happen going forward. But I think when you talk about AI today, most people associate it with generative AI. And in generative AI, it's all about generating content. And personally, I often use this as a starting point where I think that the general population really got up generative AI. And that's when they released DALL-E 2 in April 2022, so about 3 years ago. And then you could write small short prompts such as this one, and then generate photorealistic images that captures people's imagination, and we find it interesting and stimulating to look at. So in this case, it's teddy bears mixing sparkling chemicals. That's mad scientists and steampunk style. And the challenge here is that this piece here contains extremely limited information. So most of the things is not said. It's extremely implicit. But in order to actually generate an image, there is so much detail, so many specifics that we need to fill in order to actually get an image. So for example, just take some simple things. Pairs, which means that it's a plural, but it doesn't say 2 or 3 or 5 or 10 or 100. So then we generate a 2. There's this with chemicals. Here, chemicals, whatever is happening in the middle, or is this strange test tube, so whether it is sparkling, it's definitely something sparkling there in the middle, and that scientist, well, I guess you have to judge that. But the point here is that even though that most things are not stated, we still find these images interesting. But it's not only images, it's also video. So this is videos generated by Sora. I mean, this was actually released about a year ago. And again, just like with the images, you write a prompt, you basically describe the different shots in this scene, and then the computer models can then generate these videos automatically without any human intervention. And of course, we're doing things that typically are like reflection of water, and reflection in sunglasses, and neon lights, and so on. So what you now see is basically it's possible to generate kind of on-demand video content, and you just need to describe what you want the video content to be, and then it can automatically generate it. And you can imagine, I think from an educational point of view, for example, if someone has a question, you ask a question, then you generate a video providing an answer for that. Or if you're interested in watching a movie, you can just say, do you have a book or something that you wish to turn into a movie? You can just choose what actors you want, what style you want, how long you want it to be, and then you can just generate a custom-made video or custom-made movie for you. So I think the opportunities here are really, really endless. But it's not only images and video, it's also music. So you can generate music using this kind of tools. So if you need some specially designed music for you, that's perfectly possible. But if you're looking at more, I think most people use these large language models, where you basically can interact in natural language.
Because most things in our society and our culture is language based. Can you turn down the volume again? Sorry. It's very confusing when you hear yourself because it gets a bit delayed, and then you don't know what to say because you're listening to yourself. Okay, thank you.
No.
No.
Just a minute. Professor, it's not necessary anymore the headphones.
Can you just take them out?
Everyone can hear now better than you are with them.
Good. So then I've just removed them. And thank you. Much better. Now can you hear the background? Okay. So let's go back to the large language models. So why are these so significant? Yeah, because most things in our society and most things in our culture are language based, which means that now it's basically accessible to these tools, but also that we can use them to work together and to work towards improving culture and society. So I really think this will have major impact. I also think the number of applications, the number of things we can use this language model for is basically infinite. It's of course very easy to think about this kind of generating text, but I think that's probably just a very small application. I think it's much more interesting to use it to improve your own writing. So for example, if you have a draft of a text, then you can ask, I mean, how can I improve this? Or what would be the best counter arguments to my argumentation here, and so on. So really using it as an interactive tutor to help you improve your writing. But it's also the case that computer programs is just another form of text. So I mean, computer programs are also text, which means that these language models can also be used to generate computer code, or to use it for debugging code, or for using it to help you improve your programming skills. And personally, I was quite positively surprised that I just wrote like some sloppy sentences describing roughly what I wanted, and then it could just generate a program that actually almost did what I wanted. And then I could have an interaction, say that, can you please add this feature? And then I went through the program, added the features I asked for. So you basically could give it instructions on how to change the program, and it gladly did so. And I didn't even use any kind of special purpose tailored models, but I think I just used ChatGPT in that particular case. So it's clearly the case that it can also significantly help us with programming activities. But it's not only it can help us humans with these programming activities, the language models can actually use programming to help answer questions that you ask it. So one of these things that these language models are very bad at is math. They don't know math. You can ask it math questions, but it would just make things up most of the case. But what it does now, for example, if you ask it to multiply two large numbers, is that it will actually generate a computer program that computes the answer to the problem, runs the program, and then gives you the answer. And then you have a language model which basically transforms the questions we asked into computer code, runs these tailor-made, on-demand generated programs in order to answer our questions. And I think this kind of interleaving or integrating programming as part of these language models is really very interesting. And I think it can also be extremely generic in what it can be used for. But it's not only about this kind of writing assistance, it's also about information retrieval. So some people argue that this will be a major problem for Google, for example, which is then the main search engine. Because now people will ask the questions instead of asking for the links and then finding out the question themselves, finding out the answer themselves. They just ask the question and get the answer right away, so that they can replace search. And I think even Sam Altman said last week, basically, I've stopped using Google, but I guess probably marketing as well. But anyway, I think there's still more people are starting to use this language models for this kind of activities, and I also think we are starting to see this more tailored kind of search systems like Perplexity, which is then combining search with these language models. But I also think a super interesting application is this kind of document summarization. Well, summarization is maybe not super interesting, but you can interact with large volumes of complex documents by using this language model. So instead of reading all the documents yourself, you can basically have a dialogue around these documents. So saying, find me the 10 similarities between these documents, or find all the places where these documents are inconsistent, and so on. And then to get a lot of value out of the system. So my expectation here is that we'll probably be using these kind of interfaces to interact with large document collections. I mean, like legal documents and contracts, and just searching. I mean, it's not searching, but answering questions across all the documents you have in your organization, for example. So clearly, there's many things that language models can do. Now we also see these more reasoning models, basically trying to not only have this kind of next token prediction, but actually also trying to be more sophisticated in how it produces output. And I will come back a bit more to that later. And one application that is now also starting to come is this kind of deep research. So basically, you just write in what you want, compile a research report on how the retail industry has changed in the past 3 years, use bullets and tables for necessary clarity. So that is what you want to do. The system then asks you follow-up questions so it can clarify what you really want to do. And then after you have confirmed that this is what you want to have done, then the system will then start to basically search for relevant documents and relevant reports and so on. And then it will collect all these documents, analyze it, and then basically generating this research report to whatever length you want and whatever format you want, and so on and so forth. So I think this is the type of applications we will start see being built on top of these language models. So I think this is quite interesting.
The list of references.
Yes, you will get references and
Yes,
everything. They might even be correct. They might even be correct.
Generate the reports with the reference and refer in the right places in the text.
So it's clearly the case that we are seeing very sophisticated applications, and then it becomes interesting to ask yourself, where are we on a kind of more broader scale? So normally we separate into a number of different types of AI systems, and the types of AI systems we have seen so far, at least, has been this artificial narrow intelligence or weak AI, where you basically have AI systems that are at least as good as humans, but only on one or maybe a small number of things. And this is what we have seen so far. The next step is this artificial general intelligence, sometimes also called strong AI. And then you have AI systems that are at least as good as people on all things. So the point here is to be general and being able to do all the things that we can do. And then this would basically correspond to human level intelligence. Of course, people are now starting to argue that these kind of large language models maybe have reached this. Personally, I find it very strange to associate next token prediction with general intelligence, so I wouldn't say we have reached it yet. But on the other hand, I don't really see any technical reasons why we shouldn't be able to reach it. So my expectation is that we will reach this kind of human level intelligence, because we already know how to make human intelligences, something we know since the start of things. So I think we will be able to do this. And I don't think actually maybe the impact on society will be that dramatic, because as I said, we know how to do this already, and we know how to deal with population growth and these kind of things. So maybe it's not a huge difference in that respect. But the next level is, I think, the more trickier one, and that is if we achieve is what's called artificial superintelligence, and that's when you have this AI system which vastly outperforms people on everything, and then it becomes much more unclear what the consequences on society is and so on. Here, I'm not even convinced necessarily that it's possible to do it, but I guess we will find out. My personal opinion is probably we'll see much more merging of humans and AI systems rather than just completely external things. But I guess we'll see what happens. I also think that this will have a major impact on society in general, but also on work. And the reason is that I think it will be used basically everywhere. And one of the studies that I think have looked at this was done by about a year and a half ago, and they studied 700-800 consultants at Boston Consulting Group, US consultancy company, and came to the conclusion that those consultants that were using AI managed to finish more tasks in the same time. Each task took on average 25% shorter time, and you also increased the average quality with 40%. So you basically got more, faster, and better by using these tools. And I don't think any company or organizations don't want to see this kind of benefit. So my expectation here is that it will be used, and it is used, and we will see basically redefining many kind of workflows and many types of professions thanks to this. There is another positive thing from this study, and that is those that benefited the most from these tools were the junior consultants, because then they could now carry out activities or tasks that previously required more competence or more experience than they had. So basically, it seems to be lifting the lowest level rather than kind of cutting out the lowest level. So I really think this shows that it's complementary and helping these people, not replacing them. But I think an interesting consequence of this could be that those that had the least benefit were the most experienced people, the most skilled people. And this is probably something I expect, namely that if you are an expert on something, you are still significantly better than these tools. So on your particular area of expertise, you probably don't have that much use of systems. And then you might end up in a situation, if you're a company or an organization, you want to evaluate, are these tools good for us or not? And then who do you ask? You probably ask the most experienced person in the organization to evaluate these tools. And then they are probably the people who have the least benefit from them. So they might then come to the conclusion that, well, maybe it wasn't that useful, but then it's just because they asked the wrong person. I should probably ask the latest employee or something like that, and see if they had more use of it. So I think this, the consequence here is, I think it will have a major impact on work and society. And since it will have a major impact, it's also important, of course, that we introduce this technology in a good manner. So in the EU, I think we have taken a good stance, namely that the stance is that, yes, we want AI, but we don't want any AI. But we want AI that we say is human-centric and that is trustworthy. And with human-centered, we basically mean that the value is not the AI systems themselves. They have no intrinsic value. The value is what they how they help us as individuals, as society. That is the value we should realize, the human value in this. And with trustworthy, that was actually the task of this high-level expert group that I was one of the members of. So we developed these ethical guidelines for trustworthy AI that was released in 2019. And there we defined that in order for a system to be trustworthy, it should live up to the rules and regulations that are applicable. It should satisfy 4 ethical principles. I have them on the next slide. And it should have a robust and safe implementation. So it's not enough to have good intentions. You actually have to build good systems. And if you satisfy these, then you could argue that you are a trustworthy system. Of course, the devil, as always, is in the details. So it's very easy to state all these kind of principles. Actually, many organizations have done that. The hard part is really how do you actually realize them. So what we did was that we started with the principles. We defined requirements that are more software engineering requirements. And then we also did some assessment lists with basically with questions you can ask in order to see if you're working towards these principles or not. And the ethical principles that we used, or that we set forth, was respect for human autonomy, meaning that these systems should complement, augment, and empower people, not replace them or compete with them, but really complement them. They should also prevent harm, so they should be both safe and secure from a physical and a mental perspective. So we want them to be safe to use. They should also be fair in a broader sense of the word, so there should be equal distribution of both benefits and costs associated with these systems. And finally, they should also be explicable, meaning that we should have some understanding on whose behalf these systems are working. There's about transparency and these things, so that we can estimate whether what these systems produce actually is relevant for us or not. So this is the 4th principle. And since we have released them, the EU Commission has then worked on developing a regulatory framework, starting out from these guidelines. And now we have what's called the AI Act. So then this is what's called what's called a risk-based approach. So if you want to put an AI product on the market in the EU, then you need to estimate the risks associated with this particular product. And then depending on the risks associated with the product, there's different amount of regulations that apply. And there is even a category of unacceptable risks, where if you end up in this, well, it's not allowed to do it at all. And here we have examples like social scoring. There's also subliminal manipulation, and so on. So there are a number of things which are actually prohibited. And actually this category is now in effect. So the regulation was came to effect in August last year, but then it's like a gradual step where the different rules are introduced gradually. And this unacceptable risk was actually came into effect now in February this year. And then you have the high risk category, which is probably the most interesting category. And this is then applications where there's a high risk for individuals, say medical applications or HR applications and so on, where there's a major impact on individuals. Then there is a lot of regulation that you need to satisfy before you can put the product on the market. But then the expectation is actually that the majority of applications should be low risk, so there should be no further regulation needed. So this is all work in progress. And then, of course, it becomes interesting to ask oneself, this kind of generative AI that we see today, is it trustworthy? And this is an example of an image that I generated. Well, I generated an image for a talk, and I used Delhi. So actually, we have, at Linköping University, we made a Microsoft Copilot available to all employees and all students. So everyone has access to these kind of tools. And I just used it to generate an image for a presentation. I used it for a while, and then at some point I started to look at the right-hand side of the image there. And then I started asking myself, which side of the car is this car actually driving on? Because it looks like it's driving on the left-hand side of the road, but at the same time it looks some kind of Alp landscape, I don't know, maybe. And I don't know if there are any countries where they have left-hand side driving, where they have this kind of landscape, maybe there is. Otherwise, it might even be driving against the traffic. So yeah, now it's become less clear. There's, of course, also a lot of different lanes, and just merge, disappear. There's also this that looks kind of like exhaust fumes or something, but it also looks like an electric car. It doesn't really make sense. So I mean, the point here is more that often when you generate these kind of images, if you just look at the foreground, everything looks quite nice. I mean, it looks fine. But then when you start to look into the details, you often find a lot of these very strange things going on. And I think it's not a coincidence that images was one of the things that we started with, because we as humans are extremely good at both ignoring and filling in the things so it actually makes sense, even though it might not make sense in reality. But we can also take this video that I showed before, and now I want you to look at the legs of the lady here. And I mean, they look kind of wobbly and kind of a bit strange, but and she takes a bit strange. But then they also switched place of the legs. I think it was a bit jump there, but now. So I think it's nice that the shoes are still on the right foot, so that's very convenient. And I mean, she's taking a bit of jumps and looks a bit strange. And then the legs change back again, so maybe now we have the right leg on the right place. We can also see that she was carrying a purse in her hand, and now they zoom in, and probably a lot of errors here as well. So another thing that usually is strange is if you try to read. Now I cannot read this anyway, but if you were to read it, it probably just wouldn't make sense. But anyway, now just zoom out again, and now we can see that the purse is gone. So unless she has very large pockets, the purse just disappeared. And this just shows that it's difficult to get this kind of temporal consistency when you generate longer videos. And the reason is that it basically just looks at a short sequence before it, so it doesn't know what happened 30 seconds earlier. It only knows the last few seconds. So this just shows again that even though it looks very nice to a large degree, when you look at the details, there are a lot of strange things going on. And of course, it's the same thing with these large language models, that they will produce things that just isn't correct. And just to explain a little bit how these language models work. So I mean, we have this. I mean, the first part is this GPT, which stands for Generative Pre-trained Transformer. And the generative part basically means that what you learn, what you produce here is a probability distribution, and it's a probability distribution over sequences of text, often called, we used to say tokens, because you translate the text into numbers, and you call these numbers for tokens. So you first translate the text into tokens, and then you feed these tokens into these models, and then you estimate the probability of the continuation. So then you learn what is the most probable next token in this sequence. So that's a generative part. Then you can sample from the probability distribution to generate different continuations. And it's pre-trained, meaning that it's been trained on a large volume of generic text. And you can basically throw any type of text on it, because it doesn't need to know what's in it. It doesn't have to be consistent or anything. It just tries to fill in the blanks. So it basically removes parts of the text or tries to predict how the text will continue. And because it has the text, it has something to compare against. And that's why it also calls this self-supervised or auto-regressive learning, because it basically learns from the text it has. And transformer, the T stands for transformer, and it's just one particular type of neural network architecture that's used in this kind of systems. And actually, this GPT model has been around for a long time. So I think GPT-3 came in 2020, and GPT 3.5 came in 2022 in the spring. So I mean, these models have been around for quite some time. They're useful, but basically they're statistical models of how the training data works. So they're quite generic. So what really made it much more useful, which was then included in this ChatGPT that was released in November 2022. And what it did was this kind of fine-tuning. So basically what it did was that it's no longer a generic, but rather you want to make it more specialized. And here there are a number of different methods like instruction fine-tuning, where you then fine-tune it on specific ways of making instructions, or you fine-tune it on different domains, or you fine-tune it on human preferences, this reinforcement learning from human feedback, where we as users tell the system what we like and what we don't like, and then it tries to improve the model so it produces more things that we want and less of things we don't want. And that was then what really made everyone more excited. Then we have added, after that, it's been added another layer called the retrieval augmented generation. So basically, this doesn't change the model, it only changes the input to the model. So when you type a prompt in, say, ChatGPT, it will then analyze this prompt, find relevant background information, relevant context, and so on, and then it will extend the prompt and then send this extended prompt to the language model. And through this, we can significantly improve the quality of the answers. So this was then what existed in the first, and now the last year we have started to see this kind of reasoning models, as they are sometimes called. But basically, the idea is that instead of just taking the most probable next continuation, we can now start to search. We can basically try out multiple different ways of continuing this. And one technique is called a chain of thought. And basically what happens is that the language models then have an internal monologue around whatever you asked it about, and then it generates different types of answers, and then it summarizes these answers, and then provides you with a summary of all its internal thinking. And in this way, it can then produce better answers. And here, I mean, if you're using the OpenAI models, they don't make this explicit, so you don't see the internal chain of thoughts. But if you're using the Chinese models, this DeepSeek, then they will gladly show you all the internal thinking that's going on, and it might even be in Chinese and other languages. So then you can have a better understanding of how it actually kind of came to its answer. So what we also see is this kind of progression of where do you invest the compute. We started out with this kind of pre-trained scaling, where you basically just make the models larger and larger, and then you spend more compute on training the models. Then it was post-training scaling, so basically doing this kind of fine-tuning and so on, where you then improve the models after the training. And now we also see this test time scaling, so you actually have to invest compute to just for each particular question or each particular usage of it. And I mean, what we're seeing now is maybe seconds, maybe minutes. I don't know, people maybe have been running it for hours, but you can imagine what happens if you run this for years. What type of answers could we get then? So I think this is really interesting going forward. So now that we have kind of described a little bit how the technology works, now of course we can ask ourselves, can you trust ChatGPT? And I would say no, you cannot trust ChatGPT. But if you are aware of this, it can still be extremely useful. So I'm not arguing against using it, just making you aware that you need to be active and also critical in the way that you use this. And if you are, then I think it can be extremely useful, beneficial. But we also, of course, want to do something about this. So I lead a relatively large EU project called TrustLLM, with the goal of how can we make these systems more trustworthy and more factual. And basically, we are trying to do this from a bottom-up perspective. And so basically about data collection, doing pre-training, doing fine-tuning, doing this kind of testing, and so on. And the reason is very simple, and that is actually, I think, the main source of trustworthiness in these kind of models is the data being used. And if it's something that we don't know about these large commercial models, is exactly what data has been used. So it means that it's going to be extremely hard to really be able to trust them, because they will never tell us exactly what's included, and they probably might even know it themselves. So that's why we want to do this from the ground up. We are not starting from scratch, but we're actually working with companies, universities, organizations, which has experience. So we have AIICS Sweden has been developing a Swedish model. Fraunhofer in Germany has been developing a German model. TNO in the Netherlands have been developing the Dutch model. Midein, it's an Icelandic company. They have been working together with OpenAI, improving support for Icelandic in ChatGPT, for example. The problem there seems to be the tokenization. So when you tokenize Icelandic, you need many more tokens compared to English. And since the quality scales with the number of tokens, it means that quality in Icelandic is worse. So we really try to take these organizations that know how to do this, and then we join forces, and now we want to build better models. And I should say that our focus is on reliability, fairness, and explainability and reasoning. We cannot do everything, so we are selecting a few things. This is mainly a research project. I mean, it's a research project, so research is our kind of main focus, but we also actually want to train models, both to evaluate our research, but also because I think that's that's kind of artifacts that we are building. And of course, we need to evaluate them, and we want this to improve over time. So our high-level goal is to develop at least one model every year, and we want them to be increasingly better over time. So what we have done now is we have done a relatively small 7B model just as a baseline, so that we have something to compare against. So we have done the pre-training. Now we're working on the fine-tuning and alignment, and then we will do the evaluation, and then we hopefully can make it useful. And as I said, we are starting from scratch. Actually, I would say that the number one priority, and I would say the biggest headache, is really data, and both data access and data processing. So what we would like to do is, can we set up a data processing pipeline where we can then encode the different compliance requirements into different types of filters or processes, so that we can take data and put it into the system, apply these processes, and then get out compliant data in the end. Because then currently it's basically extremely manual labor to go through all the different data sets to determine what they contain, what you are allowed to do with them, and so on. So and I mean, that's why only the large companies can do it, because they're the only ones can afford to spend all this manual labor. As we want to try to automate as much of this as possible. Unfortunately, the lawyers do not always agree with this, so we're having a constant argument exactly of what you're allowed to do or not. A second challenge when it comes to this trustworthiness is data. Data composition, or the availability of data. And this is just a kind of snapshot of the amounts of tokens we have for different languages. And we can see we have a huge amount of data for English, so English not a problem. Programming code, also plenty of code available. Actually, German was not too bad. You can see Dutch there, and we have Swedish, so it also shows up. But then you have many other languages which doesn't even show up. And I mean, we are working with the different Germanic languages as our main focus. And there we have Faroese. So the Faroe Islands is a small set of islands outside Iceland. Basically, there are 30,000 people living there. I mean, how do you deal with such a small language? So that's one of the challenges, because we know that if you want good quality in all the languages, you basically should have uniform. You want as much data in all the different languages, and you want high quality data in the different languages, and that's harder to get. So if we, for example, have English, then you can be very aggressive in your filtering, so you can remove everything that's not very good. But if you have extremely low resource language, you basically have to take everything and you duplicate it and have several instances of it just to get more of it. And then, of course, you reduce quality. So here we have a huge challenge to deal with this kind of multilinguality. So one of the things that my group has been working on in different contexts is synthetic data generation. So basically, the use case that we have been working with is if you have medical data, you have sensitive information that you cannot use directly, at least. So what the idea is that you can then learn a generative model of this sensitive data, and then you can use these generative models to sample, to generate new data sets, so that these new data sets have the same statistical properties as the original data, but where you cannot trace the data back to individuals. So it's private in the sense that it cannot be returned back to individuals. And actually in this process, we can also deal with bias and representativity. So for example, we can remove the statistical correlation between sensitive attributes. So we can do that in the training process. We can also, when we generate the new synthetic data sets, we can then redistribute it so that it actually captures the real representativity in whatever group we're interested in. So there are a number of benefits in using this kind of synthetic data. And now we're interested in, can we apply this also to textual data? So that's one open question we're interested in. We're also interested, of course, in this increasing the factual correctness. And here we think that the best way to deal with this is actually doing this retrieval augmented generation, basically using knowledge so we can populate this background knowledge with things that we know are true and trusted, and then we can use this to extend the prompt so that when they generate answers, they become more factual. And this is basically the kind of standard way of doing things. We're also interested in looking into how to use knowledge graphs and other kind of knowledge representation tools to further improve this. But this only handles the static case. If you have dynamic knowledge that changes over time, then you need other types of methods. So basically today, all the data we have is atemporal. There's no temporal information unless written there somewhere explicitly. So how can we extend this kind of retrieval augmented generation approaches with an explicit notion of time, so that you can start to ask about things at different time points, and thereby being able to deal with this kind of dynamic knowledge. We're also interested in kind of integrate more reasoning approaches, and when we talk about this with neurosymbolic approaches and so on, how to combine more data-driven and more knowledge-based approaches, and that's also something we're interested in. So that was a little bit about factualness. We're also, of course, working on alignment. So if we want to make them trustworthy, we need to align basically the implicit values of these systems with the values we want the system to have. And there are a number of different ways to approach alignment. So here are the three most common ones. So of course, you can do it when you do the pre-training to make sure that the values in your training data is as well aligned with what you want as possible. And then you take advantage of this in the pre-training. You can have explicit instruction fine-tuning, where you then have specially designed data to deal with different types of instructions. And finally, we have this preference fine-tuning, where we're then asking users to provide their input on what they want. So we are, of course, combining all these different approaches. But what's actually interesting is that there's been research showing that just having 1,000 high-quality examples can be enough to really make a difference in this kind of alignment. So what we're now doing is that we're explicitly collecting high-quality alignment data in all the languages that we are covering. And then the intention is to make this available. We're also working on evaluation, because evaluation is really hard. And the way I usually try to convey why it's hard is to use this example of the famous move 37 in these AlphaGo games, where basically the computer made a move that all the human experts thought was a terrible move. But then in the end, the computer won. So objectively, it was a good move. But subjectively, from the human expert, it looked like a bad move because it was unhuman. It wasn't a move that we normally do. And now you have this interesting situation. And if you ask the best human experts, they would say, this is bad, don't do it. But then in reality, it actually was a good thing. And how do you deal with that? Of course, now it's just Go. Maybe not that important for most people. But you can imagine that this was a medical recommendation system. And now you have an extremely competent and experienced medical doctor asking one of these systems for advice on some case and getting some advice back that he or she does not really, I mean, from their point of view, does not make sense. But now the interesting question becomes, on what grounds should the medical doctor follow the advice, or on what grounds should the medical doctor not follow the advice? Because there's no safe alternative. I mean, both could be very good and both could be very bad. So there is no neutral choice, and you have to make a choice. And I think this will become trickier and trickier because, of course, we know that it has much more information than we do, but probably we have other things that can compensate. So I think this is really key. How do we evaluate these kind of systems? There are a number of different ways of doing this. You can just use your gut feeling. Everyone does that at some point, of course. Just, does this feel good to use? You can do that in a bit more systematic way. You can ask many people what they feel. Do they think it's good? Then at least you can average over all the different users. You can use language models to judge is what it produces correct, good, bad, and so on. And you can use benchmarks. So there are a number of different approaches. We are focusing more on the benchmark, which is what most of the community is doing. And we have, of course, also developed our own benchmarking tool. So it's called Scandeval, which has a focus on the Scandinavian languages, because that's what we can uniquely provide to the rest of the world. So we have this multilingual benchmarking framework, which can then evaluate a large number of languages, but over a large number of different tasks. So both language understanding, like text classification, linguistic acceptability. So actually, this is quite an interesting one, where you want to evaluate whether it produces correct output. And one thing that we noticed was that if you ask it, for example, to generate, say, German, it gladly generates things in German. But then after some time, if it's mostly trained on English, basically English becomes its native language. And at some point, we just switch back to English. So if you try to get these kind of large models to produce some language for a long time, at some point, it's likely that it actually switches languages. Extractive question answering, named entity recognition. We also evaluate on more generation tasks like summarization, world knowledge, common sense reasoning, and so on. So we try to kind of get an overview of the kind of main things we want to test. Of course, we have leaderboards and these kind of things as well, if one is interested in seeing the result. So to kind of conclude this Trusted LLM presentation, I mean, basically, we are trying to develop this trustworthy actual large language models. We do this in this process of working with data curation, pre-training alignment. We're also working with model transfer. That's another approach to deal with low research languages. Try to basically do transfer learning between languages in a systematic manner. So that's what we're currently working on. I mean, I think it's also interesting. The question is, will the current approach towards language models be sufficient? Where we have this basically data-driven machine learning approaches, just scaling things up. And I don't think so. I think this will not be sufficient. I don't think that will solve everything, but rather I think we need to look into other types of methods, including this more symbolic knowledge-based methods, and finding ways of combining them. And then this neurosymbolic AI is then the concepts being used as a label for these kind of approaches. And we can now see it also showing up on the Gartner hype cycle as one of these innovation triggers. So I think if you want to look for something that helps develop the next generation of AI models, I think this is one area to look into. And to conclude this talk, I would just want to give some trends, what I see going forward. So of course we can have ask ourselves the question, will these large language models just continue to grow and grow and grow? And my guess, yes, probably they will. But I think we will also see much more specific domain and domain tailored models that are then much cheaper and much better at those particular things. So we can make them more energy efficient and more economically viable, because it would probably be too expensive to run the largest models. If you're running millions and billions of queries, every day. So I think that's one trend. Another trend is this multimodal models. So basically what we have now is tuning models, so either text or image or video or sound. But how do we integrate all of this? And here the challenge is to get this cross-modality alignment. So how do you align between different modalities? So for example, if you generating sound and say faces, you want the facial expression to be aligned with what the person says. So otherwise it just become very strange. How do you generate this kind of alignment data for those kind of things? That's tricky. Reasoning models, we're talking a little bit about that. Generalization from language models to world models. So currently the language models are grounded in language, which means that they're just grounded in other text. They have no sense of really what the physical world is like. So here, of course, it does not work well if you want to use these systems to control robots or other things that actually need to work in the physical world. So I think one very interesting direction is how do we make these models grounded in the physical reality so that what they propose or what they produce actually makes sense in the physical world. Agentic AI is another one of these things that is a lot of focus on, where you basically start to have, instead of having just a passive language models where you ask it questions and you get some answer back, you actually have models going out, searching for information, acting on our behalf, doing things for, so being more agentic in its behavior. And I mean, this kind of deep research example I showed is an example of a simple version of this. Neurosymbolic AI I already talked about, as I think will be the next wave of these kind of systems. And of course, we also mentioned that there's several Brazilian researchers working on this. So actually one of the leading people are from Brazil. But in the end, I think what we really want is, of course, how do we make these systems trustworthy and human-centered? Because in the end, it doesn't really matter what the technology does or what the technology can do, but rather what is the value being created for us as society. And I also think it's extremely important to realize that this is not a question of either AI or human. It's really a question about AI and human together in solving complex problems. Thank you very much.
Thank you very much, Professor Fredrik. It was a pleasure to be here, to learn so much from you, from our experience. And we have a few minutes for questions. Let's say, I don't know if we can stay here for 15 minutes.
Yeah, sure.
How are you feeling this extension of time?
That's okay.
Are you
I
okay
just have
with
to be back
that?
at 4 o'clock at the other place, other side of the plane.
Okay, let's start with the first question there.
You talked about how you're trying to make LLMs available for different languages.
Yep.
And what do you think about simply, because I'm sure this is an idea that someone came up with at some point, simply translating an input, say in Icelandic to English, because your model is much more well-trained in English. Like, what issues could arise from it?
So first of all, how do you do translation? You need a language model to do the translation in the first place. But it's actually, that's one way of generating synthetic data. So that is one way of providing training data is to use translation. But one issue is, for example, cultural references. We have looked into that, and I mean, often the examples come from one cultural context. So if you translate that just literally, it's kind of perfect literal translation, but from a cultural point of view, it does not make sense. So therefore, you need also, authentic data in the different languages. It will not be sufficient just to do translation.
Well,
Okay.
I've heard somewhere that someone was competing with AI using a kind of mechanical Turk approach. So you ask something, and then the system distribute the question to hundreds and thousands of people, and someone can just answer that just in less time than the AI. Well, that's the beginning of an approach. For example, in the case you said of medical advice. So I'll cite something that happened with me. I went to a doctor and he couldn't discover any way to help me. Then I went to Dr. Google and searched in academic Google and found a number of papers describing my symptoms as a very rare disease. And I sent back to the doctor. And the doctor said, oh, I know a friend of mine that might have been touched with this kind of problem. And he took a biopsy and sent to this doctor. And in the end, yes, that's that very disease that's in this paper. And it just, he got me medicine that costs $5, and I was cured. So the idea is that you could have some kind of mechanical Turk, and this case was that friend of this doctor that he knew, and he had a specialty because it's a very rare disease, and the medical formation don't touch all the very basic.
So I think there are a number of interesting aspects in that. First of all, if you have very rare things, statistically it's never correct. So it's very difficult to deal with rare events in general. Secondly, we're having these multiple different experts. Actually, that's what this, for example, DeepSeek is one of these mixture of expert models, where you basically have several models and then you choose between them. So it's also being integrated into the models. And finally, when it comes to this kind of mechanical Turk or using humans, I think it's probably much more common than we know. If there is, for example, in the self-driving cars, they are not fully self-driving. Sometimes they get stuck, and then someone needs to take over and manually solve the situation.
There's a mechanical Turk.
Yes, so I mean, it's basically a combination of humans and AI that makes it work. And I think that's also a positive thing we should.
I have a simple question. So you said that the EU agency now is following. So there is an EU agency that is following this AI protocol you showed. So you have these EU guidelines on AI. So there is an AI agency already working on this,
so there's an AI office which is supposed to help do the implementation. But the actual specifics is also going to be determined through standardization. So there's a lot of standardization work going on in determining the specifics of this regulation. There's also being set up national competent authorities. So in each country, there should be an authority for interpreting and helping with living up to this regulation. So there's much more structure under the surface.
And my question is, okay, so it seems that the goal here is the original data, is the core data, or is so in some sense, is it expected that a company should disclose what kind of data they use for training the model?
Yes.
It is
okay. I mean, there is this transparency requirements, but there you have this interesting kind of collision between trade secrets and this. That companies, of course, argue that this is a trade secret and we are not allowed to share it, and it might influence the stock market and all kinds of stuff. So exactly where the boundaries are is unclear. There's also this Digital Services Act, which is also expecting that you make data available. So I mean, yeah, I think this transparency is something that there is a lot of push for. but it's unclear how far one can get with that.
Thank you so much for your time to present us this amazing content. And you finish your presentation with the key phrase in my mind, that we are talking about AI, computers, and human. And my concern is when we are talking about a good and trustable AI, and comparing with the human dependence of AI more and more, how we can predict 20 years over time the usage and the dependence of AI for the human, because we are generating more and more data, especially young generation. They are depending of the tools, but they are not looking for the source, looking for the fundamentals. And so how we can balance the use of tools and also the competence of cognitive learning for the individual.
No, but I think that is, to me, what I associate with this kind of critical and active use, that you not become a passive, just swallow whatever is being produced, but actually actively, critically analyzing it. But of course, that's a more sophisticated cognitive ability, and I think that's probably where I would focus the kind of school part of this, to take this kind of critical approach. I mean, my expectation is also, I think that in the tools themselves, they probably will become better at kind of providing explanations or motivations and kind of why things are. So if you're just willing to dig in a little bit, hopefully it will also make that work simpler to be more critical. I think if there's a risk that we become passive, and that I think would be very negative, we have to actively support us to be more actively and critical.
My question is about the transparency requirements.
Yes.
So, older AI technologies such as state machines and behavior trees, I consider them completely transparent. You can look at them, oh, that's what it's doing. But now comparing it to LLMs nowadays, I see them completely opaque. So, how does LLMs nowadays enter these transparency requirements, and how do you see it changing for maybe fitting, maybe not fitting these transparency requirements in the future?
So first of all, I think I would argue that I don't agree, or rather I would say that the neural networks are equally transparent, but just larger. And the problem is, I mean, the reason why you can understand this behavior tree or this other method is because it's small. So if you have a 10 billion node behavior tree, you will be equally lost. So I think it's more a question of scale than the kind of methods. And I mean, if you take the neural networks from a mathematical point of view, we know exactly how they work. I mean, the neural network is just a mathematical function. So in some sense, it's just having a mathematical function. The challenge is it's large. So you cannot, I mean, it's just billions and billions and billions of parameters, so you cannot grasp what it means. So yeah, that's the first part. But then when it comes to this transparent, there is a lot of work on this kind of mechanistic interpretation, so trying to understand what these mean. There is also work on kind of tracing, that if you ask this question, what kind of parts were triggered, what part of the input was used, and so on, so that again you can improve your understanding of this. So I mean, there is a wide variety of different types of techniques that's being developed to improve both the transparency and the explainability. So I think we will see improvements, but the challenge is very much in evaluation. It's hard to evaluate whether it's what's a good explanation or what's a good interpretation. So there are some methodological challenges.
Let me talk about, thank you so much, it was really good, especially for the neuroscience. We talk a lot about AGI, but do you think AI should be endowed with feelings, should be sentient?
Yeah, well, that's, so I think the problem there is that we don't know what it is. So I mean, I think it's very clear that it's possible to build AI systems that behave in a way as if they had feelings. So behaving in a way that for an external observer, it looks like it. I mean, that we can do, we have been able to do for quite some time.
Yeah.
So, but that doesn't tell us anything about, does it have feelings? Then the next question becomes, should we, or is there a value in it? And actually, I mean, you could probably argue that in order to have proper interaction with humans, actually emotions is a natural way for us to express things and to have a natural interaction you might actually want to have. So yeah, I think it might be useful from a human robot or human AI interaction point of view. I'm not sure, maybe something we want to focus that much on. But when it comes to sentience, I think that's much more tricky because we know that we can realize more and more entities are sentient than we thought from the beginning. So apparently we are kind of moving what we consider to be sentient all the time. So maybe it will include these things. It's very weird to me, but maybe.
In that sense, if this is the case, the last bullet would have to be reviewed.
Yes, because then you get all these ethical aspects of what are you allowed to do to such a system. But I actually think then, So I think that's discovery deserves.
Oh, thank you. Thank you for the presentation. I was watching.
Okay, yeah, sit outside.
For the broadcast. Well, my concern is the alignment problem.
Yes.
Once I think it was Malcolm Gladwell that once said that autonomous cars should have some kind of variability, so that people don't know exactly how the car will behave. They don't just jaywalk on the streets. So, and even in narrow domains, within narrow groups, I think there is much variability in decisions, in human decisions. So, when you talk about alignment problem, I'm thinking second order, how to provide some variability, and what the statistics of that variability would be. So is it important? Do you think it's an important thing?
So I mean, yes, I think it's important, and I mean, I actually think randomness is probably much more important than we think. And I think you can actually use the game theory as an argumentation. So I mean, if many games, if you just take this rock paper scissors, for example, the optimal strategy to play rock paper scissors is to be completely random. So it's only when you're completely random, there's no information that the other player can act on. And then you have the optimal strategy. And I actually think in many cases, the optimal strategy is to be random. And then you get this variability. The problem is that no one likes randomness. So it's like making this argument for research grants, for example, that usually all the research grants that are above some kind of threshold, it doesn't matter that much which one is actually funded. And I think even prove this that they're adding randomness to the process, increase the quality, but no one likes randomness. So I think there you have this issue that I think from a purely kind of optimality perspective, I definitely think variability and randomness is key. But from a society governance point of view, we really dislike randomness. And I think that's a tricky thing to reconcile. And because I think it's also, this jaywalking is an interesting question because, of course, you want the systems to be unpredictable so that people don't just rush out in the middle of the street. But on the other hand, you say, so you want cars to hit people from time to time, which is, of course, not what you want, but that's the argument that would be made. So even though it makes a lot of sense, it's very difficult to make it in a kind of a legal governance context to make that kind of argument.
Just very quick, two small questions. The first one is about federated learning.
Yep.
That's it's about privacy, but privacy in the context of being open is also not so good. So how can we deal with that? And the second one from the robotics field, and we are seeing a lot of small generative models that are being used over traditional time series analysis. How do you see those things?
So actually, we have been working with time series. So we've done a lot of work on generative time series models. I think the challenge there is evaluation, but we can talk about that later. Because if you look at the statistical properties, they look fine, but then you look at the individual trajectories being generated, they're crap.
Yeah, and digital twins is being an
So we're working on that. So that's something we're very interested in. But then going back to this federated learning. So, I mean, we are basically trying to explore different paths to deal with this, and I think federated learning is one. The challenge is, of course, that if you still can extract it from the model, it's questionable how much you gain from it, but at least you don't need to copy the data, you just need to move the model around.
But then you cannot check from the AIICS that if the data is going to be used, it's fair enough.
Yeah, I haven't thought about that angle, so
it's complicated.
Yeah, no, I see your point. So basically, you're saying that the requirement in the AI Act is that you should be transparent about what training data you have been used. But then in the federated learning, the whole point is that you don't want to make the data available, because the whole point is to
privacy. Yeah. And there's privacy points.
But I think you don't need to share exactly. I mean, this is the data file. Okay. It's more what type of data. So you say, oh, we have this 10 hospitals, and they have this kind of hospital with electronic health record. Then that might be sufficient. But I mean, my experience is that there's so many of these places where the kind of intention of the law and the technical capabilities do not necessarily match.
Perfect. Yes. Thank you very much.
Fredrik, question from the audience.
Yeah.
Can we? Okay.
So we're talking about the data to train models, and I want to know how can we treat that data thinking in the human error, feeling that data. Because, for example, you buy a game in Steam and you do a dislike the game, but in the commentary you say, best game I've played in my life. And it's a good example, but if you go for example, in a hospital or a clinic, and the patient don't know exactly how to fill that formulary, but it should be meted, and how you treat that data that the human can error fill in.
So I mean, I think that's an excellent question. I would say today there's basically manual. I think that there's a lot of manual work in making the data more uniform and improving the quality. But actually, I think what this highlights is one of the major weaknesses of the language models, and that they have no sense of certainty, no sense of how sure they are about their answers. So I think we need to have more explicit representation of uncertainty, and then you can also model the potential error or the quality of the data and take that into consideration when we do the training. But today, I don't think there is. You don't do it. You just hope for the best and average out.
Hey, 2 or 3 years ago, I used to see a lot of fear around AI and a lot of talk around the dangers of AGI and ASI. I think that today, as the technology got more accepted, the fear has quieted down a little. But at the same time, I see a lot of AI agents getting better at like cracking captchas, the human tests. We used to only press a button, now we have to identify all sorts of crazy things. And I've also seen some papers around generative AI being used for cyber attacks, like creative attacks. And my question to you is, what would you say to someone that is worried that trying to regulate and align AI and maybe over-regulation might slow down the process of becoming vulnerable, might leave someone vulnerable, or a country or a regulated country vulnerable to attacks from an unregulated country or institution or group?
So maybe it's not a politically correct answer, but then you can imagine, I mean, just hiring more police, will that remove crime? I think the challenge here is that it's very hard to enforce, and it's very hard to basically see if anyone is living by it. So basically, I mean, we had this discussion before, I think in some sense, maybe the best is actually make it as public as possible, because the more hidden you make this kind of development, the harder it will be to actually know what's going on, and it will become easier to become manipulated or doing these things. So kind of contrary, it might actually be beneficial to make it more public. I mean, if you want to, there is actually a very recent AI safety report. So Joshua Bengio was tasked to do this kind of survey of risks related to AI. So this report was released, I think, 10 days ago or something like that. So there is also a lot of studies around the risks associated with AI, and also where are we in the terms of mitigation. So basically the idea is to find ways to mitigate these risks. And actually I think one thing is really that we need more, let's say, publicly funded research, because hopefully that's more aligned with the society compared to the more commercial drivers. So it seems to me that a lot of these people say that it's basically the challenge is more the, when the economical incentives is the only thing that drives the development, then you can end up in an unwanted position, as we need something to counterweight that. And we also need to work together globally, so that because there is not much point in if all countries except one does something, if the last one does not. So we really need to work together, and that's why there are these kind of, like this AI Action Summit that was in Paris last week, was one of these events where the different, both from academia and from industry and from the political side, are meeting and discussing how we can constructively work on this going forward.
Gente, encerramos as participações.
Two questions from the audience.
Não, nós
Okay.
Nós encerramos, já são passados um quarto de hora do meio-dia. Would like to thank you again very much for considering all questions that have done here. And I would like to invite you, eu gostaria de convidar vocês, em nome, inclusive, do pedido da Stefanel Albuano, que foi uma chamada importante desse encontro, foi aquela que nos trouxe o Fredrik Heintz aqui, to a picture. Então, pedir a vocês que façam uma aproximação aqui para a gente poder tirar uma...
Sem pânico, não tem.
Sem pânico, com calma.
É mais fácil do melhor ele virar para cá e todo mundo tirar para Eu acho que ele vai ficar lá e aí todo mundo para cá, é melhor.
Pode ser, vai ser.
Façam o arranjo aqui.
Não faltinha dirige.
Não, todo mundo pode sentar, gente.
Fica
Melhor sentar
e ele vem para cá.
A gente tira a foto de lá para cá. Ele fica mais organizado, senão vai ficar uma loucura.
Perguntar, quem vai tirar?
Eu não vou. Eu tiro a foto. Não tem problema. Tiago, você pode tirar a foto?
Não tem panorâmica no cenário?
Tem.
A panorâmica.
Gente, se pudéssemos acender as luzes no auditório, talvez estejam... Aí, ó.
Vai ficar um pouco escuro.
Agora não sei como é que eu vou conseguir apagar o... Gente, eu realmente não sou uma pessoa que fazer isso.
Pode ser, você quer tirar?
Like a selfie.
Now you want me to start now?
I don't know. I see the director. He stays here or
no? He stays here. Você consegue que ele saia?
Foto? É isso.
Okay. 3,
She's
Say yeah.
Energy. AI.
Say AI.
AI.
Okay.
Obrigada.
Na apresentação,